Here we have a function f of x. We need to find its domain, or in other words, we need to find all those values of x for which f of x exists. F of x is real. Now, what sort of a function is this f of x? It is a square root function. And what is the only restriction that it has? It's radicand. The term which comes inside the square root cannot be negative. Why is that? Such a number does exist, but the problem is that it is not a real number. It will go into the complex number area. It will not be a real number. So the only condition it has to satisfy is that the radicand has to be positive. So we need all of those x for which this whole term is going to be positive. Now, what sort of a function is it? It is a polynomial function of degree 2. It is a quadratic equation, but there is a small problem. It is not in one variable. Technically, x and mod x, you cannot take them to be the one and the same. They are same only if your x is positive. If your x is negative, modulus of x will be minus x. So we will be getting two different values for x. We cannot have that, but then there is a good news. What do you have here? X square. And what do we know about x square? Not just about x square, not just about 2. Any even exponent, what do we know? Their values and their mod values will always be same. Whether x is positive or negative, it does not matter. X square and mod x square will be same. You can just put values. Put 2, you will see both are same. Put minus 2, you will see both are same. And this is not just for 2, it is true for every even exponent. Only for even exponents. Please remember that. It is not true for odd exponents. This is not true. Can you tell me an example why it is not true? Take x is equal to minus 1. Then x cube will be equal to what? Then this will be minus 1. But then modulus of minus 1 is what? It is actually 1. So 1 cube is going to be 1. Minus 1 and 1, of course, they are not equal. You're going to get two different answers. Again, it is not just for 3. It is for every odd exponent. This is equal for even exponents. Here we have a 2. We have an even exponent, which means instead of x, we can put a modulus x in its place. So there. Now do we have a quadratic equation in just one variable? Yes. What is that variable? It is mod x. So here if you see the leading coefficient is minus 1. It is better to make it positive. So how will we make it positive? Multiply throughout with minus 1. What happens when you multiply throughout with minus 1? Multiply or divide with a negative number. The inequality flips. Now you can easily factorize it, right? How do we factorize it? We are looking for two numbers which when multiplied give 6 and which when added give minus 5. What are the two numbers? Minus 2 and minus 3. There. I have just factorized it. Now, why am I factorizing it? So that we can go to the basic, the standard formula. What is the standard formula for a product of two linear factors to be less than or equal to 0? X should lie between A and B. I am taking A as the smaller number. The condition for the product of two linear factors to be less than or equal to 0 is that X should lie between A and B. It lies between, here your A is 2 and your B is 3. Now what is the standard formula for this condition? When is modulus of x less than or equal to a? What is the solution for this? The solution is that x will lie between minus a and a. You can check it for yourself. Randomly give me a number. Take 5. Take a is equal to 5. What will all of those numbers whose mod value is less than 5? What are those numbers? Give me 4, minus 4. 3, minus 3. It is all of those numbers from minus 5 to 5. All the numbers with 0 in between. 4 and minus 4 3 and minus 3 2 and minus 2. So if you want the solution set for modulus of x less than or equal to a, it is just this interval here, which is minus a to a. And in case you are wondering what is the solution set for modulus of x greater than or equal to a, again the same logic follows. Modulus of x less than or equal to a, if this is your answer, the complement, the inequalities are complements of each other, which means what? The solution set will also be the complements of each other. From the entire number line, just remove the solution set that you see here. Then you get the solution set for this. So now we are going to combine both of these conditions but for different a. What do you have here? Modulus of x is less than or equal to a, which means what? A is an upper limit. Modulus of x cannot exceed 3. It has to be always less than 3, which means what? In this condition, your a is actually 3. What is happening over this side? 2 is less than or equal to modulus x, which means what? Modulus x has a lower limit. That is what is happening here. Your a is less than or equal to modulus x. So you have two different conditions. We are just going to combine both. First condition, modulus of x is less than or equal to 3, which means x belongs to minus 3, 3. Modulus of x is greater than or equal to 2. 2 is a lower limit, which means what? There. And what do? You have to take the intersection of both, not the union. Remember the intersection. Whenever you hear the word and, modulus of x has to be greater than 2 and it has to be less than 3. Remember, whenever you hear the word and, what you are looking for is intersection. But then if you hear the word or, modulus of x has to be greater than 2 or it has to be less than 3, then what you are looking for is union. Please remember, it is the same in the set theory. Whenever you hear the word A or B, what you are looking for is A union B. When you hear A and B, what you are looking for is A intersection B. This is just plain set theory that we are going to use here. We are not looking for the union. What we want is the intersection. Let us find the intersection. Let us first mark the important points. Minus 3, minus 2, 2 and 3. What does the first condition say? X should lie between minus 3 and 3, which means all of this part. Right? And what does the second condition say? It should lie from minus 2 to minus infinity and 2 to infinity. If we were looking for the union of both of these conditions, what will we take? We will have to take the whole of the number line, because we have got everything covered from minus 2 onwards to minus infinity, 2 onwards to infinity, and the place in the middle also. We have everything covered. But what we have is, this is the first condition and this is the second condition. What we need to take is their intersection, because it has to be a domain which satisfies both the conditions. Both means what? Only the places where they both overlap. Where do you see them overlapping? This area. Here. And do you see them overlapping here? There. Here also they are overlapping with each other. So this is the only common part where they are overlapping. So it is minus 3 to minus 2 union 2 to 3. We have found out that this is the domain. We will take a number which is not in the domain and see what happens. What is the first number that comes to your mind? What about 0? 0 is not in the domain, right? So let us put 0 here. So this whole thing becomes 0. This whole thing becomes 0. And you just end up with a square root of -6, which is bad news. We cannot have that. Now what about 2.5 or even 2? Take 2 because this is an open bracket, right? Open bracket means what? 2 and 3 are both included. So take 2 for example. So here you will have a 10. Here you will have a -4, -6. You will have a square root of 0, which is no problem. It is still 0. It is not negative. And you can put 3 also. Try putting 3. You will get 15 minus 9 minus 6, which is again what? Which is again 0. As long as you don't get a negative radicand, you're fine. So this is the domain that we were looking for. Till I meet you again, you take care. Assalamu alaikum.